In this video, we're going to have a look at multiplying and dividing fractions. And we're going to take a look at what are some of the rules, what are some of the ways that we need to simplify these things, and how is dividing fractions different than multiplying fractions. That's today on High Peak Education. What's going on, everybody? Hope you're having a wonderful day. So for this video, it's going to build upon the previous video where we looked at simplifying fractions. We'll look at two ways to multiply fractions, multiplying them first, then simplifying them, or simplifying them first before you multiply them. That's the easier way in my opinion, as you'll see. And then we'll also look at the nuance of what you must do to divide by a fraction. So let's have a look at today's content. Remember, last time when we were talking about fractions. And remember, we were talking about how important the greatest common factor is. There's another companion aside from greatest common factor today, which goes along with those trees, which is called least common multiple, which I hope you've heard of before. But that one's going to particularly help us when we're simplifying fractions, but when we're getting a common denominator. So remember, some of our target ideas were the following. Know how to multiply fractions. We wanted to know how to divide fractions. We wanted to know how to add and subtract fractions, and then we wanted to compare and identify. We've done some multiplying fractions, and we've certainly done a lot of reducing and comparing fractions. Remember from last time, we really spent some time developing this idea of greatest common factor, GCF. We developed this idea of greatest common factor because the idea was that we know a fraction is most reduced when we've divided by the greatest common factor. Remember we went through all this?
Yeah.
And we basically said that, look, when we get it down, if one number is prime, the only way that the fraction is not reduced is if that prime number is a factor of the other number. Otherwise, if both numbers are prime, we're done. But if one is not a factor of the other, we're also done. Like for instance, 4/9 is done, even though 4 is composite. 4 is 2 times 2, right? But 9 is 3 times 3. But even though they're both composite, it's done because they don't share any factors. 4 is 2 times 2 and 9 is 3 times 3. So the greatest common factor between them is only 1, which, is basically nothing, okay?
Yeah.
So anyway, that's the idea. So we kind of went through all this. Basically, what I'm just going to briefly say to you is we're going to keep coming back to this idea, but let's kind of move past it for now.
Okay.
Just kind of as a brief warm-up, I'm going to recommend we do the following multiplication problem. Let's go 4/6 times 3/20, okay? So we're going to multiply those. Now remember, like I said, there's two ways to do this. You can either just multiply straight across and then reduce like we were doing last time, or we can cancel out factors before we begin. So I'm going to suggest let's do it both ways.
Okay.
So let's do the longer or the harder way. And this one's going to be the way where we just multiply, then reduce. So the longer, harder way is to just multiply, then reduce. So how would you multiply these across to get a fraction that results if you just multiply?
Okay, so I would start with the numerators, which is 4 times 3, which equals 12.
That's right.
And then there's 6 times 20, which is, work that out on paper.
So it turns out, what's 6 times 2?
12.
12, and there's an extra 0. So it's 12 with an extra 0, which is 120. 120. So hopefully this is what you have, right?
Okay, yeah.
See that?
Mm-hmm.
Now, because we didn't cancel anything before we began, we need to reduce. So can you just look at those two numbers and identify what is the greatest common factor? Look carefully. Remember, a greatest common factor can be an entire number itself. So let's think about 12, right? 12, if we started the tree, would break down into 4 times 3, and then what does 4 break down into? Now if we start off with 120, again, you can start off however you like. You can start off with 60 times 2, 40 times 3, I meant to say. But you could also start off with 12 times what? Because it ends in a 0. 12 times what? 10. Okay, hopefully this is something that you learned earlier in math, right? Anytime something ends in a 0, it's divisible by 10, right? So like 120 is 12 times 10. The whole idea is that we're taking the 12 and we're shifting it over. When we do that, we're effectively adding a 0 and we're multiplying by 10 because our number system is base 10, right? Yeah. Base 10 means if I give you 10 $1 bills in American money, what would you give me back? What kind of a bill? 10. A $10 bill, right? 10 George Washingtons, if you've ever seen those, gives 1 Alexander Hamilton, right? Not that Hamilton's, famous or anything with the musical now, but so, 1 Alexander Hamilton, right? Okay, so a $10 bill. Suppose I have 10 Alexander Hamiltons. I have 10 $10 bills. I give you those 10. You're the bank teller. You give me back 1 what?
100.
A $100 bill, which is a Benjamin Franklin, right? So you think about this. 10 ones is 110. 10 tens is 100. 10 hundreds is 1,000, right? And so on and so forth. But the reason I bring this up is because our number system is base 10. The next column is always 10 of the previous column. You agree with that?
Yeah.
Always 10 of the previous smaller number. Like 10, suppose I have 10 100 millions. Then I get, 1 billion, right? If I have 100 million, but I go 10 of those, I slide over to the next column, which is 1 billion.
Okay.
I mean, that entirely makes sense, right? Because it just keeps going.
Yeah.
Now, the reason I bring all that up is because if you take 12 and you sort of slide it over one place, I hope you can see that you get 120, which is just, but then sliding over one place is times 10, okay? That's a little review of early multiplication, but it's something you should be aware of, okay? So that's how I knew this so quickly. Now, by the way, do you see that we can start the tree for 12? But do you see how the tree is going to be the exact same thing as this entire tree right there?
Yeah.
I mean, we don't even necessarily need to write it. It's just going to be the same exact tree, right?
Yeah.
This is like, again, and remember the analogy I made before. Think of 12 as having 2 bones and a circulatory system. And then this thing has the 2 bones, but it also has a circulatory system, but then this also has a muscular system, right? The 120. It has one more component. Anyway, the reason I bring all this up is because what do we want to take 12 over 120 and divide by to get it in lowest terms? Yeah, by 12. Good job. So if we divide by, just like you were saying, 12 over 12, we should be dividing by the greatest common factor, right? In fact, what is the greatest common factor in this case?
The tree, right?
Right. You do the tree and you compare 12 to 120. But what is the greatest common factor between those two? Well, they entirely share all of what's in red here, don't they?
Yeah.
So what number do they share? We just said it.
12.
Yeah, they share 12. Because don't they share 2 2s? I mean, we could just finish this, right? 3, right? They share 2 2s and a 3. You agree with that?
Yeah.
Now this 10 here, by the way, would split into 5 times 2, but that's unique to 120, right? 120 has a 5, which 12 does not. And 120 has an extra 2 that 12 does not.
That's why it has 10. 10 is 5 times 2. Does that make sense? Let that sink in for a second, okay? So think of factors as components of numbers, right? With all that in mind, we can then go one step further. We can then say, okay, if 12 is the greatest common factor, we divide by the greatest common factor, we should get the most reduced fraction. So what's 12 divided by 12? Yep, that's right, 1. And then what should be 120 divided by 12? Yeah, 10. If you're not sure, that's where the tree is sometimes helpful.
Yeah.
Do you see that if you follow the tree down to 12 and you divide by it, 10 is sitting right there. That's the answer. You see what I'm saying?
Yeah.
So once you do the trees, like the tree should help you do anything else you need to do. Okay, so then 1 over 10 is the answer. Now, in my opinion, that's the harder way. Do you know why that's the harder way? Because the numbers are bigger. So this is going to be bigger numbers. Now, I don't know about you, I like to avoid big numbers when possible. So instead, what we're going to do is I'm going to suggest let's now do the easier way. So the shorter or the easier ways before you multiply, reduce first. Now let's talk about reducing, and I'm going to use a different color for each time we reduce.
Okay.
Reduce means we want to divide by factors that make the multiplication problem smaller numbers. So let me just get you started here. Here's an example. Do you see that 3 and 6 have a common factor?
Yes.
What is that common factor? 3. So we could divide this by 3 and get 1. And then we could divide this by 3 and get 2. You agree?
Yeah.
Okay. So there we go. Now it turns out we might not be done. And the reason is because as long as you're canceling something on top and bottom, as long as there's more factors, there's more reducing to do. By the way, do you see that the 3 we already did there is the same thing as this 3 right there?
Yeah.
This 3 right there. Now, because the greatest common factor is 12, we've only taken care of, so we already know the GCF, 12. 12 is the same thing as 3 times 2 times 2, right? Because it's all the shared stuff, right? The 3 and the 2 2's. So we've already taken care of the 3, but we haven't taken care of the 2's. So what do you think? We still need to divide out 2 2's. Let's say how we do that. I say, oh, wait a minute. This is a 2. I can divide that out and make it a 1 as long as I divide something upstairs that's also divisible by 2. And where would that be?
Be the 4, so 4 divided by 2.
Yeah, it's 2. You see that?
Yeah.
Okay. And then so that takes care of this one, right?
Mm-hmm.
Now one more step. We need to divide by 2 again. Well, take a look. What numbers that remain are divisible by 2?
The 20.
The 20 is, and then what else is? This 2. You see what I'm saying?
Yeah.
So that's dividing by 2 gives 1 and gives 10 here. And wait a minute, look at that. Look at what we end up with. We end up with 1 over 1. We end up with 1 over 1 times, 1 over 10. 1 over 10. You see that? After all the dust settles, so to say, we end up with 1 over 1 times 1 over 20. Well, I don't know about you, I can do that pretty easily in my head. What's 1 times 1?
1.
1. And what's 1 times 10?
10.
10. I don't know about you, I think that was easier.
In the center there?
Yeah. So if that's the case, then I would suggest do it this way. If you don't want to get lost, then I just suggest rewrite it each time. Remember at first we divided this by 3, we got 1 and 2. So if you want to, and by the way, there's absolutely no shame in doing this. There's 0 shame in doing this.
Okay.
You can remake this 4 over 2 times 1 over 20, like that. Does that make sense?
Yeah.
Because the 3 became a 1 and the 6 became a 2. And
Yeah.
then do just as we did before. You can do divide this and this, make this a 1, make this a 2. And then again, do the same thing. Just rewrite it. Just make this, let's see, 2 over 1 times 1 over 20. Okay? Now, by the way, even if you didn't realize you can simplify 2 and 20, you see how you'd get 2/20ths, which is the same thing as 1/10?
Yeah.
But hopefully you realize, oh, wait, I might as well just finish it up.
Okay.
This is 1, this is 10, and I hope I don't necessarily need to rewrite it again. It's going to be, 1/10, right?
Yeah.
So if you need to rewrite it, just do that. There's no shame in that. Okay?
Yeah.
Okay. Now, by the way, if you understand what we just did, you more or less understand multiplying fractions.
Okay.
Okay? Because multiplying fractions is always straight across, and you either simplify early, which is what we were doing here, or you simplify at the end with the greatest common factor. There's actually an old statement. My cousin was in the Army, and one of the things he told me he really learned is this concept of pay now or pay later. Sometimes he would finish a drill and he'd be sitting in his locker and he'd have an extra 5 minutes to himself.
Mm-hmm.
When he had an extra 5 minutes to himself, here's what he said was like the key lesson he learned. He said, if I have 5 minutes to myself, I spend that extra 5 minutes cleaning up my locker. Because in case they come around for a inspection, like a sudden inspection, I don't get reprimanded. So my locker's nice and clean, and then so everybody's really happy with me, nobody gets mad at me.
Yeah.
But what he's doing is when he has the extra 5 minutes, he's paying now. Paying now, that's the second method here. Pay now. You sort of have to reduce things early on. The method up above is pay later. Now, pay later is usually harder because pay later is, hey, if I have this extra 5 minutes, I'm just going to sit here by my locker and chill out. If somebody comes around and then my locker looks dirty, I'm going to be running laps. I don't like that. I don't like running laps. But in any case, I have to pay later. So you either pay now or you pay later. Generally, paying now is easier, but you have to be careful because, again, you're either going to have to pay now or pay later. Does that make sense?
Yeah.
Okay, so that's a little analogy I often remember when I'm reducing fractions because you have to get it down to its simplest form. But you got to do it either early on or later on.
Okay.
Does that make sense? Suppose you had 5 over 14 times 7 over 20. Yeah, I would recommend that the second method, in my opinion, is better.
You start.
You don't necessarily. Now, here's the thing: you can start off with whatever simplifying you want in terms of the steps.
Alright.
It doesn't matter which factor, as long as it is a factor.
Okay.
Okay?
7 and 14.
Definitely. What would be the common factor there?
7.
I agree. So you're saying divide this by 7, divide this by 7, and what are we going to get when we do 7 divided by 7? 1. And then what are we going to get when we do 14 divided by 7? Yes. So you're telling me that if I edit this equation, you're going to end up with 5 over 2 times 1 over 20. Okay? I agree. Okay? I agree.
And greatest common factor, would it be 10?
I don't think 10 is the greatest common factor. I think 5 is only divisible by 5, but not 2.
So then.
Yeah, 5.
Okay. So then. Okay, divide 5 by 5. So then you end up with 1/2 and and
20 divided by 5, 4.
right?
25 divided by 5 would be 5, so 20 divided by 5 would be 4.
Yeah.
And then if we spend a second to just rewrite this, we should have, let's see, it'd be 1 over 2, like you said, 1/2, 1 over 2, and 1 over 4. Yes. Okay, and then finally we just got to multiply those, which is what number? 1 over 8. That's your answer. See how that works?
Yeah.
Okay. Now, by the way, if you don't mind, again, I'm very experienced, so I'll show you the longer way, but I'll show you why it's really tedious.
Okay.
The longer way would be 35, because it's 5 times 7, over, now 14 times 20. 14 times 10 would be 140, but timesing by 20 is just like twice that, so it'd be 280.
Okay.
Now we haven't paid yet. Now we need to pay later.
Okay.
So we're going to figure out, okay, what's the greatest common factor of these, of 35 and 280. So 35 breaks down into 7 times 5, which are prime numbers, which we're done. 280 breaks down into, let's see, 35 times 8, which is not obvious. Okay, I would actually probably break this down into 28 times 10, and then 28 breaks down into 4 times 7, 10 breaks down into 5 times 2, and then 4 breaks down into 2 times 2. But hopefully you see that out of all this, the only shared factor is, well, 7 and 5, which is 35. So the GCF is 35. So if you divide both of these by 35, you get 1 over 8. Now, in my opinion, that's harder.
Yeah.
It still gets you to the right answer, but it's harder. Okay? Is that okay, though?
Yeah. I definitely
Okay.
like the other one more.
Yeah, I like the canceling method better.
Yeah.
When we divide by a fraction, we have to perform one additional thing that we don't usually do. So let's suppose we take the same numbers we did before. 4/6 times 3/20, 3 over 20. But instead, let's divide them. So let's divide them instead, okay? Now, when you divide fractions, it's basically the following. Dividing fractions gone over by the following rule, okay? Dividing by a fraction is the same thing as multiplying by the reciprocal, which we know to be basically what we would call the flip of the second fraction. Dividing by a fraction is the same thing as multiplying by the reciprocal, or the flip of the second fraction. Now, by the way, there's one more thing I want to mention about this out loud, and this is like apparently the most common little rhyme that I hear, at least in Colorado. Like, it seems to be sweeping the Front Range. The little rhyme to remember this is what people often say is copy dot flip. Copy dot flip. What in the world does that mean? Well, it just means we're going to flip the second fraction, and instead of a divide, we're going to have a dot. So what this means is we're going to have 4 over 6, and instead of divided by 3 over 20, it's going to be times 20 over 3. By the way, in algebra, we will definitely need to be able to do this, because we'll sometimes be dividing by entire fractions that have x's in them and variables. So we have to be able to know how to do this, okay? We have this going on, so dividing by 3 over 20 is the same thing as multiplying by 20 over 3, okay? So, by the way, here's the way I often remember this. Suppose I wanted to do, let's say I wanted 6 divided by 2. Isn't that like taking half of 6? Let that sink in for a second. If you divide 6 into 2 groups, isn't that just like taking half of 6? 6 divided by 2 is the same thing as 6 over 1 divided by 2 over 1, right?
Yeah.
Any whole number is just divide by 1, right?
Mhm.
And I'm being a little pedantic, but let's think about what that really means. If you divide by 2 over 1, isn't that the same thing as saying 6 over 1 times 1 over 2? Because remember, half of, think about this. This means half of. Half of. Of means multiply in math, right?
Mhm.
You know, if you have basketball teams, each basketball team is 5 players, but you have 4 of them,
Mhm.
you do 5 times 4, right?
Yeah.
4 of them. So 5 times 4. So if we want to do half of 6, you would just get 6 times 1/2. And you would get, well, you could divide these by 3 and 1. So you would get 3 over 1, which is 3. But that entirely makes sense because 6 divided by 2 is 3, right?
Mhm.
Dividing 6 into 2 groups is the same thing as saying take half of 6, which is 3, right?
Right. Yeah.
That makes sense, right? So dividing by a number is the same thing as multiplying by its reciprocal, its flip.
Okay.
That's how you know it's correct.
Okay.
But in any case, we can just kind of finish this up. Now it's a multiplication problem. Can we divide 4 and 3? Does that have a common factor, 4 and 3 there? No. I think there's only one simplification we can make. 6 and 20 have a common factor. What common factor is that? They're both even, so what? Yeah, 2. So this would be 10. 6 divided by 2 gives what? 3. So I think we're going to have 4 times 10, which is 40, over 3 times 3, which is 9. Now, believe it or not, even though those are relatively large numbers, I think we're done. Because 40 would break down into 8 times 5, and then 8 is going to break down into 4, 2, and then this breaks down into 2 and 2. 9 breaks down into 3 times 3. Are there any factors shared? 2, 2, 2, 5, 3, 3? I don't think so, right?
No.
So I think we're done. So the
So-
greatest common factor between 80, if you had multiplied this, you'd have gotten 80 over 18. The greatest common factor between 80 and 18 would have just been the number 2. I mean, not everything simplifies really beautifully, but in this case it did just a little bit. Let's try another example. In fact, why don't we just try the same numbers we did with the other one, except with dividing? Yeah, why don't we try 2 over 3 divided by 5 or 7? So let's try 2 over divided by 5 over 7. Okay, so what's the rule when you're dividing by a fraction? Copy dot flip, which is the same thing as dividing by a fraction, is the same thing as multiplying by the reciprocal, which is the flip, the second fraction, right? That's more the full-blown form. So what would you write here? So you copy, what do I write? There you go. Okay? Now can we cancel anything? No, 2 is prime, 3 is prime. 7 is prime, 5 is prime. Since they're all prime, unless there's like one of the same numbers, we can't cancel anything. Do you see that?
Yeah.
Can't cancel anything. So we just got to move on. So we need 2 times 7, which is what? 14. And then 3 times 5, which is 15. And notice that you might think, they're both composite numbers. Well, no. I mean, 14 is 2 times 7, we just found that out. And then 15 is 3 times 5. We're done, right? We can't simplify that.
Yeah, that makes
That's
sense.
it. Do you want to try one more, or do you think you got this?
I think I have it, but I want to try one more.
Okay, let's try one more. Let's do 3 over 8 divided by 2 over 6.
2.
Good.
And then you have, there's nothing that you can cancel.
Just one thing. Careful.
Oh wait, is it the 8 and the 6, they have 2?
Yeah, they have a 2 in common. Yeah.
I would rewrite 3 over 2.
Not 3 over 2, but 3 over 4, right?
Oh, so you don't divide that? You don't divide the 8 and 4?
Well, so you just rewrite the number that resulted after the dividing, right? So you have
Right.
3 over 4 times 3 over 2. You see that?
Okay. All right. Yeah.
And then what did we get when we multiply?
That's 9.
9 over 8. Yes. Okay. And then that's done because 9 is 3 times 3. 8 is 2 times 2 times 2. So we're just no factors shared. We're done, right? Is that okay?
Yeah.
Adding and subtracting fractions. When it comes to adding and subtracting fractions, so we're going to do this next time. That's the one that requires common denominator. So adding or subtracting fractions, this one is the one that you need a common denominator. So that's just a reminder. I know you've done common denominator before in your life, but it's definitely something we got to review. By the way, the one thing that most people don't realize is that the common denominator, this is basically, we usually want the least common denominator, the LCD, which is actually based upon the LCM, which would be the least common multiple.
Right.
Now, the factor trees also tell us about least common multiple as they do greatest common factor. We have to get to that later. But again, least common denominator is based upon least common multiple. Okay? So we'll get to that next time. And then the next time with number 4 with comparing fractions, I'd like to show you a couple examples of like actual shapes which are cut up into various things and see how you can identify fractions from there. And that's just good to know, especially like when you're working with real things, okay?
Okay.
So what we saw in today's video is that when you multiply fractions, you have to multiply across numerators, multiply across denominators. You can do that to start a problem, and you can simplify at the end, dividing through by the greatest common factor of the numerator and denominator to know if you're in lowest terms, simplest form. Otherwise, you can simplify before you get started in a fraction. Make sure that something on top and something on bottom gets simplified by a common factor. And then you can multiply, and then you're paying earlier, paying now, and then you won't have to pay later. You'll end up with a simpler fraction. In fact, in lowest terms, when you're already at the end. Remember, with dividing fractions, you are going to multiply by the reciprocal of the second fraction. That's copy dot flip. So hopefully you understand how to multiply and divide fractions now. Remember, as the end of this video previewed, we don't need to do common denominators when we're multiplying or dividing fractions. That will save for another day. So stay tuned for more episodes here on High Peak Education. Let us know in the comments how you're going to use this information in your class, in your life, and otherwise. Please smash that like button if you enjoy this content. Please share this amongst your social networks. Please subscribe to the channel, and thank you very much for watching. I will look forward to seeing you in the next video.